Hi everyone, welcome back to my channel. Today we are solving a fun string problem from EatCode, and it's about creating the longest palindrome using two-letter words. Before moving ahead, I strongly recommend you to pause the video and give a try to the question by yourself at least for 10 to 20 minutes. I hope that you have gone through the question. Now, let us read the problem. You are given an array of string words. Each element of the word consists of two lowercase English letters. So, the length of each word is 2. Create the longest possible palindrome by selecting some elements from words and concatenating them in any order. Each element can be selected at most once. So, this means we can iterate through the word once and we can either select that element or not select that element. That's it. Return the length of the longest palindrome that you can create. If it is impossible to create a palindrome, return 0. So whatever palindrome you create, you have to return the length of the longest one. A palindrome is a string that reads the same forward and backward. I hope that you know what is a palindrome, but still I am saying that GG, if we read this GG from forward to backward, it is GG, and if we read this GG from backward to forward, it is GG. So this is a palindromic string. But if we read this word from forward to backward, it's LC, and if we read the same word again from backward to forward, it's CL. Since it is not same, so it is not a palindrome. Let us go through some examples written here. Let us go through example 1. We are provided with LC, CL and GG. Here there is only two cases. If LC is found, then CL must be there to make this string palindromic. So we found, so if words are given to us as LC, CL, GG, then we can say that longest palindrome that we can form is LC, GG, CL, or CL, GG, LC, right? So if we look at the length of it, it returns 6, right? So I think that the question is clear now. Let us look at the two cases that we get from here. Since each element of a word consists of two lowercase English letters only, we have two options. Either it can be same or it can be different. So this is a case of palindrome, and this is a case of not palindrome. Right? So whenever we see a palindromic string, we keep a count of it, and whenever we see a non-palindromic string, we keep a count of its reverse string, right? If GC is present, then there must be a CG also present to make this a palindrome. Otherwise, this will never get palindrome, right? Let us go through the first example. We are initially at LC and we will say that okay, we have seen a LC, but this does not contribute anything to the string. I can't add it to my string because I have not yet seen CL. So let me rename it as unmatched pairs. Let me just add a 0 here so that we can keep a track of its length. Initially we have length 0, right? Now I came here and I see LC. So will I increase my palindromic string length? No, LC is not a palindrome. So the length of the palindromic string will be 0 only. But what we will say that if we get a CL, if we get one CL, then there will be one match case, right? So what we say that we add our CL to the unmatched case and move this forward. Once I came here, I will see that this is CL. Is CL present in unmatched pairs? Yes, CL is present in unmatched pairs. Then I will be adding 4 here. Why 4? 2 for CL and 2 for LC. Are you getting it? 2 for CL that we have seen now in unmatched pair, and since it is present in unmatched pair, that means its match has already been transversed. So I will add a length of 4 here. After adding a length of 4, I will decrease this by 1, right? Once I found this is 0, I will delete it. Okay. Now let us move forward to the next element, that is GG, right? So GG is not an unmatched pair. Let us name it same letter words. So let us add our GG here and count it by 1, right? Once I get out of this loop, I say that oh, I transversed every element and this is my all the balanced pairs. But remember, in this balanced pair we have not considered the same letter words. So before returning, I will have to check if any same letter word is present or not. If it is present, I am just going to go here and add a +2 in it. That means add a 6 to it, right? And we will return the length 6. Here also the output is length 6. Let us go to another example to understand this case better. Okay, so initially the rest is 0, initially the unmatched pair is 0, initially the same element words are 0, and now let's start transversing. So at AB we say that okay, I have seen AB, but it does not form any palindromic string. So I will just go to unmatched pairs and say that BA is missing. I need one BA to make this AB a palindrome, right? Now I will move my index to the next. Next is TY. Okay, TY is not present in unmatched pairs. So what I will do, I will go to unmatched pair and add a TY here, YT here, right? I will say that I need one YT to make a complete palindrome, right? Now what I will do, I will go to the next element, and what next element is yt, and yt is present in unmatched pair. So what I will do, first decrease this by 1, okay, and then I will say that the length here is 4, one for yt and one for ty, right? So till now if we form string, it will be tyYT, right? So at yt I have popped 1 and I have added a 4-letter word here. That 4 letters can form a palindrome here. Now if this is 0, I need to remove this. I will remove this, right? Now I will move to my next element, that is LC. So I will see if LC is present in unmatched pairs. No, LC is not present in unmatched pair. So what I am going to say, that LC should be matched with CL. LC should be matched with 1 CL to make it a complete palindromic string, right? Now what I will do, I will just move forward by 1 and I will say, oh, is CL present in unmatched pairs? Yes, CL is present in unmatched pair. So I will go here and decrease CL by 1 and then increase this by 4. So it will become 8, and since it is 0 here, what I am going to do, I am going to just pop it or delete it, whatever. Now I am going to the next element. It is AB. Is AB present in unmatched pairs? No, AB is not present in unmatched pair. So I am going to add a BA. But wait, BA is already added. So now I will say that I need 2 strings here of BA to make this a complete palindromic string, and I will come out here. This is now out of bound, so our answer will be 8. This is what is shown here in example 2, right? And what will be the string, although it is not given to us that it is necessary to write, but just for our purposes I am going to write that LC CL CL LC we can do it in between also, like TY LC CL YT, right? And same here, YT LC CL TY, right? There can be more also, like here I can say that it can be, so it can be TY CL LC YT. So any of the cases will happen. So I think that there will be 8 strings. However, it is not our business to return the number of string that is formed. We just have to return the length of the string formed. So the length here will be 8, right? Now let us go through another example to get a better understanding, and this is an interesting test case. I am here with 0, oh, what happened? So here I am saying that I am 0. This is all empty and matched pairs is empty, right? Now let us go here and say, okay, I have seen CC. CC is the same letter word and it has appeared for one time. Now we will go to next element and we will say that, okay, LC is appeared for the first time and it is in same element. Sorry, LL is present in the first time and it is same element, right? Now it will go to next and it will say that XX is present for the one time and it will move to next element and it will be out without incrementing anything. Now when it will be out, it will be saying that is same letter word contain anything? Yes. If it contains anything, it will add here 2 and then return the answer. Why so? Because if it is a CC or LL or XS, in any of the cases they are palindrome, so at least 2 will be returned. If any one of them is, if we choose any one of them, then also 2 will be returned as the length of the longest palindrome. Alright, now let us see a modification in it. Suppose CA is present here, XS is present here, and again a CC is present here, right? So we were already 0 here, right? And we said that XS is 1 and then we move on to our next element, that was CC. When we come here at CC, what we see that, oh, CC has been appeared 1 and now it has been appearing 2 twice. And once this element is appeared twice, what it becomes is, it becomes like this: CC CC. This is a palindrome of length 4. So whenever we see an even length palindrome here, we just pop it from here and we add 4 to our result length and then we move to the next element. Now after moving to the next elements, we see that we have popped out, but before returning this 4, we will check that does same element contains anything. Yes, it still contains LL and XS. So if it contains anything, I will just increment it by 2 and return it, and that would be 6. Now let us see that how, if CC is already there, then LL can be here, right? Or CC is already here, then XX can be here, right? So this is the whole concept where we need to work around. All right, so let us go and code it. What we need to do is, first we need to pair that are reverse of each other, right? We need to pair that are reverse of each other, and then we have to do unmatched pairs. Okay, just going here. Okay, first return type is, let us define here res is equal to 0 and return res, right? Because we have to return integer. Now let us go here and take this 2 sets up. two digits of unmatched pairs, that will be initially initially empty, and the other one is same letter words, that is initially empty, right? Okay, we are just defining default dict here. Same for both the cases, right? Now what we will say, we will loop through all the words and we are only getting two type of words. If words 1 is equal to word 2, so if word if word 0 equal to word -1, right? First and the last element, what we need to do there. And then if word is present in unmatched pair, what we will do, if words will be present in unmatched pairs, and then what if the word is neither equal to nor the word is present in unmatched pair, that means this is a new word, and since it is a new word, what I am going to do, in unmatched pairs I am going to append it. You got it? What I did here? I said that unmatched pairs of the reverse word will be the reverse of the word will be added in unmatched pairs, right? And it will be incremented by 1. Now what if the words are same? Since the words are same, what we are going to do, we are going to append this to same letter word. Right? Now if this same letter word is even or is 2, because at every time it becomes 2, I am just going to delete that element. So I will say res plus is equal to 4, because suppose CC has been appeared 2 times, then it will be CC. That means the result is added by 4, and then what we are going to do, we are going to say delete the same letter words, right? And then continue. No need to go further, right? You just continue from here. Now what if we found the word in an unmatched pairs? So if we found the word in an unmatched pair, I will say that res plus is equal to 4, length will be increased, and then I say that unmatched pair of the words, unmatched pairs of the word will be decremented by 1, and then I will check if unmatched pair of the word is 0. If it does not exist, then I will say del unmatched pair word, right? And what we will be doing, we will be continuing, we will not going further because we don't want to add anything, and we will continue. Now if we come out of this loop, our res will have whatever it have. We will return this res only if same letter words is not present, only if not same letter word. Otherwise I have to return res plus 2, right? If the same letter word exists, then we have to return res plus 2. Let us try to run it. Yes, it is accepted, and then submit it. Yeah. Let us now analyze the space and time complexity. So for word in word, one for loop is loop for words. So order of n, only we are iterating through one time, so it will be order of n, and space complexity will also be order of n since we are using a ticked. So let us go here and see. So the time complexity is order of n, perfect, and the space complexity is also order of n. And that's it. Thanks for watching, and I'll see you in the next one. Till then, keep practicing.